So when you're building a system, I want you to think about who's the very first user of your system. Who's the very first person that should use it before anyone else? Anyone care to take a guess? Yep. Yeah, unit tests. Yeah, perfect. That's right. Yeah, so we want our unit tests to be the first user of our system, and they can come in quite early. They can come in before we have a database, before we have a UI, when we're just working with the core logic. So with .NET Core, we have a really nice experience. Out of the box, there's 3 testing frameworks that we can use. The first one is XUnit. That's the one I think most of us all know and love, and certainly the one we use here at SSW. The second one is NUnit, which has been around for a long time, definitely a great choice. And the third one is MS Test. Unfortunately, MS Test doesn't have a logo. I created one, but I'm not a designer, so it's probably not the best. But look, I make a joke about MS Test, but things have changed. MS Test is now a first-class citizen. It's supported by .NET Core, and you can run it on Windows, Mac, and Linux. So there's no problems there. It does everything that the other frameworks does, at least in terms of the cross-platform capabilities. What I will say is that the ASP.NET Core uses XUnit. The ASP.NET Core team uses XUnit. So I think it can kind of show that those tools such as XUnit and NUnit certainly have evolved a lot more than MS Test has in the past. Okay, so before the break, we saw that there were 3 testing tools that we could use out of the box with .NET Core. And now we're going to take a look at the testing pyramid. So you've probably seen this before. I've captured 3 kinds of tests on this pyramid. Obviously there are others, such as load, performance, stress testing, subcutaneous tests. But essentially the essence of this pyramid is that the lower down the pyramid it is, the faster and cheaper these tests will be to create, and the higher up, the slower and more expensive and potentially more brittle these tests will be. So the idea is to focus your efforts on those tests that are fast and quick, fast and cheap to create. So if you can unit test something, that's where you should be focusing your efforts. If you can't unit test it, maybe because of some kind of dependency on some kind of infrastructure, then write an integration test. And if you can't write an integration test, maybe because of some complex UI logic, then finally write a UI test. So essentially, unit test as much as possible, then integration test, then UI test. And also don't try to replicate the tests. So if you're testing, say, a mapping behavior as a unit test, which would be a really good place to test it, don't recheck that as part of your integration test because it just makes your integration test a little bit more brittle and you'll have multiple tests breaking. So let's have a look at the other testing tools that we can use to support our efforts. So these are the tools that we're using with SSW. So the 2 that I use together, whether I'm writing kind of unit integration or UI tests, are XUnit and Shoodly. And Shoodly just provides a really nice way of writing your assertions. So I'll demonstrate that for you soon. There's also the EF Core in-memory provider. So when you work with EF Core is one big abstraction, and you'll bring in providers such as SQL Server, Postgres, Cosmos DB, but you can also bring in this in-memory provider, which is a tool which is built solely for the purposes of testing, and that allows you to write tests effectively where you have a dependency on Entity Framework Core. Next we have Mock or MockQ, and this is a tool for providing test doubles. So if you're creating stubs or fakes or mocks, then this is the tool for you. It's just a nice, simple approach. Well, we also have 2 tools kind of with Visual Studio and with the .NET Core CLI. So with Visual Studio, I think 2017 plus Enterprise Edition, you have live unit testings. And what that'll do is it'll basically run your tests automatically. It'll show ticks, crosses, and dashes beside your lines of code, so you can see what has tests and is passing, what doesn't have tests, that's the dash, and what has tests but is failing. So you can get a good idea of your code coverage. And you also have the .NET Watch Global CLI tool. And you can use the .NET Watch CLI tool to actually run your tests automatically. I'll demonstrate this for you too. And then for your UI tests, typically you're going to use something like Selenium or previously Coded UI. But just keep in mind, if you're using Coded UI, Visual Studio 2019 will be the last version to support it. It has been deprecated, as have the web performance and load testing tools. And so that applies both to the project templates and to the associated Azure services. So one other type of test that I'd like to mention, and I have a really great article for you to check out, is subcutaneous tests. So subcutaneous tests are tests that operate just below the UI. So for example, in a lot of the applications we write, that's going to be at the API layer. Now with subcutaneous tests, our goal is to test the basic inputs and outputs of the systems. So we want them to be simple, we want them to be easy to write, and we want them to not test too much. So for example, if we were saying we wanted to test that we could get a customer back from the API. So to do that, we're going to make an API request, we're going to pass in a customer ID, and we'd expect to get back a customer DTO, okay? So the basic input and output we could test there is that it responds with a success status code. So a 200 or something along the lines of a success status code, but not specifically a 200. And that it returns the right type of DTO. But we wouldn't, for example, test that it mapped up first name correctly, it mapped up last name correctly, it mapped up address correctly, because that's not a basic test. We could test that better with the unit test. But the benefits of these tests is that it reduces the need for UI tests, and they're easy to write and maintain, but it's also testing the full stack. Okay, so when you hit the API layer, you're testing a little bit of ASP.NET Core, you're testing database interactions, you're testing other infrastructure interactions, so you just have to decide exactly what you do test. So you might mock out some of your external infrastructure when you do that test, but you'll probably hit at least your database, so you can test that basic full stack. And the benefit is there that when you write these tests, you're testing a lot for the time you spend writing them. They're very simple to write. So I'm not going to demonstrate that here today, but at the end, when we look at clean architecture, I have some examples of those tests in the solution that you can take a look at for yourself. They're set up, the framework's there, so it's ready to go. Now I mentioned that there's an article I wanted to share. Let me see. So if you just go to Google and search subcutaneous tests, just like that. This is the first result, so we can go. I'm feeling lucky. Save some time. Didn't work. Too quick. So this is an article I think from the ThoughtWorks team, ThoughtWorks Ministry of Testing, and it goes into great detail. It talks about the definitions, where it came from, what it is and isn't. Nice diagrams, that sort of thing. So have a look at that to learn more. And then at the end of the day, when I show you the clean architecture solution, have a look at some of those examples that are included, and that'll really help. Okay, so now I want to talk about test-driven development. So test-driven development is a workflow for writing tests first. And obviously we have two choices when we write our tests. We can write them first or last. So first, before we write the code, or last, after we've written the code. And does anyone have a preference? A show of hands, who prefers to write their tests first? Yeah, they do, but only if we give them the choice. So you're saying the business dictates that we write them first. Is that what they're dictating? Or
they want to see it working before we write.
They want to see it working before you write the tests. Okay, and that's the problem, because we gave them that choice. Okay, if we write our tests first and then deliver the feature, then there's no choice. If we deliver the feature first and then we say, are you happy with that? And they say yes. And then we say, okay, now we have to write some tests. They're like, why? We have what we need. So people talk about these two workflows. There's a test first workflow and a test later workflow, but test later doesn't work. So really, test first is our only choice. And if we're going to do test first, why not TDD? I think the kind of the decision's been made. It's no longer a question of whether we should be writing tests or whether we should be following TDD. I think we should be, and there's not really any other choice, at least in my opinion. So with TDD, the cycle is red-green refactor. So with that cycle, the first step is to add a failing test, and then we run all that tests and see that one fail. Then we write some code. We run all the tests again to see the new one pass. So the idea between writing some code there is actually to write the smallest implementation we can. And I like to think of it as a first draft. So we just want this test to pass. And it's a first draft, so we can forget about code smells, we can forget about magic strings and magic numbers. We do whatever we can just to get it to pass, because in the next step, we're going to refactor that. Okay, so that's where we get an opportunity to clean it up. Why is the first draft so important? Anyone know why? The first draft is really important because if you're a perfectionist like me, it gives you an excuse just to write some crappy code that smells. Okay. Otherwise, I'll spend so much time trying to create the perfect design that it'll just take me so much longer. So now I just write a first draft, I get it to green, and then I refactor. And I find that process is much quicker. And I might have multiple passes at refactoring, but then I'll get it to where I want it to be much quicker. So why is it important to write a failing test first? Anyone know? Right, yeah. So you'll know when it passes. Could I write a failing test just by saying stubbing out a method and throwing a not implemented exception? Because that would be red, right? Right, we haven't tested a real reason for it to fail. It's not going to fail in production because it's not implemented or because the behavior has been changed to not implemented, because that's never going to happen. So we need a real reason for it to fail. So for example, if we're getting customer by ID, we're testing that, we've passed in a valid ID, and we're expecting a customer to be returned, then throwing a not implemented exception is not a valid reason for that test to fail. A valid reason for that test to fail is instead of returning a customer, it returns null, okay, or it returns the wrong customer. So we want red, but red for the right reason, because a test that never fails has no value. All right, so let's have a look at a demo. So we're going to create and run some tests using the .NET Core CLI so we can see how it works, kind of from a cross-platform perspective. Before we do that, I might just introduce this little sample app that I've created by just creating it from scratch. So if I load up the Windows command prompt, I've just got an empty folder here. And what I'd like to do is create a new ASP.NET Core application with an Angular front end. So to do that, I can just go .NET New Angular. And there's a couple of other templates supported as well. So for single page application development, there's also React and React plus Redux. So if I go .NET New Angular, it creates the application and restores the dependencies. We can have a quick peek at it. So this is a single page application. It's got an Angular front end, and you can see that that's contained within the client app folder. And the Angular front end's been scaffolded using the Angular CLI. So it's an Angular 8 application built using the Angular CLI. And then over here, we have our ASP.NET Core application, and it's got a Web API controller providing some sample data. Let's turn those off, hopefully. And that one. So you can see here, this is just a very typical ASP.NET Core application, much like what Brendan has shown you. Now we won't use this one because if I do that, I'll have to actually run npm install, and that will take all day. So I've built another one. And I've added a few features to it. I've just added, a list of to-do items with a DB context and some shells for unit testing, so that we can work with those. So to run the test from the command line, we can just go .NET test. And that'll basically search the folder for any test projects, run the tests, return the results. check this. Looks like it's coming along nicely. There we go. My Surface Book is struggling today. There we go. So 3 tests passed. The tests aren't actually doing much at the moment, but it's nice to see that. So the other thing I can do is use the .NET Core Watch tool. So if we run .NET Watch like that, it'll give us the options that are available. We can use .NET Watch Run, which will basically serve our application and monitor the CS files for changes. And if there are changes, it will rebuild the application and reserve our application. Or we can run .NET Watch Test, which will just monitor our CS files and continue to run the testing tools whenever something changes. So if we do that, it'll... Oh, that's right. So one of the things with .NET Test is it will run all of the tests in all of the CS projects that are available. So if you have multiple test projects, it's going to keep running them. It'll run them all once. One of the limitations with .NET Watch Test is it's for a specific project. So we'll go into our test project. Let me see. dir cd, there it is. So if you're going to be running tests this way, and you have multiple test projects and you want to run it, with .NET Watch Test, it's good to have a third monitor. So let's say you had a third monitor, you had 4 test projects, then you can tile them on that monitor, you can keep them running continuously, and people will walk past and think you're ultra busy all the time because there's all this code flying on 4 different windows. And all you really have to do is just tweak a couple of things and it'll trigger it. And, So there we go, so that's running. And so let's have a look at the tests that we have. So I've created, let me walk you through the solution a little bit just to see. Where should we start? So I've created a models folder, and it has a to-do item entity. And that entity has an ID, has some data annotations, it has some notes for things that I'd like to do. It has a title, a done value, completed date and time. I've got some commented out functionality that we're going to test. In here, I've created a service. It's a to-do item service which supports getting all to-do items, getting them by ID, adding one, updating one, deleting one. That's the implementation for all of that. So we'll have a peek at that when we write some tests for it. There's nothing fancy there. If we have a look at the controller that we've created for that, we've just got a to-do items controller. We've injected the service, and then we're just interacting with the service. And this just gives us a very simple application that we can write some tests against later on that will work with when we're looking at Open API, and again when we work with validation. So I'll check this in at the end of the day and you can see all of the examples. Okay, so what I want to do is start by looking at one of the simpler tests that I've got, and it's this one. So we're saying toString given valid to-do item returns correct result. So it's not doing anything at the moment. So let's write a test. So we'll say to-do item equals new to-do item, and essentially toString is going to look at 4 of the values, so the ID, so we'll give it a fake ID, the title equals do this thing, we'll say whether it's done or not, and we'll say that it is done, and then we'll say the completed date. I think that's in there. Oh, let me add in my reference. There we go. Completed, and we'll just say date time dot now, which is fine for this. Okay, and so then we want to, so when we write our unit test, generally we're following the arrange, act, assert pattern, so the 3 A's. And so there we've arranged everything we need for this test. Now we're going to take an action and we'll get the result. So we'll say our action is .toString. And now we can assert that result. So we want to say assert equal, and being careful to get these in the right order, assert that the expected result and the actual result. So we'll leave that blank and we'll put in this. So we're expecting that toString is going to return this, because this is how we're going to write our toString method, or what we expect we'll implement it as. So actually, I'm going to make it not done because it's quicker to write a test for that. Okay, so that's how I want it to be returned if it is a not done item. So now we've written our test and we can run it. And this should be our failing test, right? Because we've written the test but we haven't implemented the functionality. Great. So, and did it fail for the right reason? It expected this, and actually what it returned was this, which is the default implementation of toString. So that's wonderful. So let's go to our class. Not there. Don't do that. And so I've got an implementation here ready to go. So this is where we write the most basic implementation. So we wouldn't really write this. We'd probably just return the value that we expect and then refactor from there. But this is pretty trivial, so we're not going to bother with that. So you can see that if it's not done, we're going to return the ID, the title, and done not complete. And if it is done, then we're going to return the ID, the title, and the date and time that it was completed. So let's just check that. So yeah, we'll just need to update this one to be not complete. And so if we run that again, then it should pass. And of course, in the background, these changes are being detected. .NET Watch Test is running continuously and actually, showing that on your third monitor. So that's good. So one of the tools that I mentioned that I like to use is Shouldly, and it provides a nicer way to write assertions. I think I've already got the package installed. Let me see. So we look at the CS proj for our unit test project. No, I don't have it, so we'll go grab it now. So manage new get packages. Actually, I'll show you from the command line, because I know not everyone's using Visual Studio. So .NET add package Shouldly, just like that. There we go. Start up our tests again. Okay, so now we can just add a using statement, and we can write our assertions in a nicer way. So instead of saying assert.equal, we'll take the expected result and we'll say result.should be like that. So that's nice. So Shouldly just provides a whole bunch of methods so that we can write our assertions in a more natural way and in a more readable way, and hopefully with less code. So now we're going to have a look at testing logic, and we're going to look at using XUnit, Shouldly, and the EF Core in-memory provider. Now, with these examples, I've tried to keep them as simple as possible just to demonstrate the points. When you're looking for more complicated examples or more real-world examples, definitely take a look at the Clean Architecture solution, which we'll show you at the end of the day. It has a few more features in it, but this should help to see how it all fits together. So I created the service for the purposes of being able to test it, and what we can see is that this service has a dependency on the application DB context, which is an entity framework called DB context. And so if we want to test this service, we either need to mock that out or use a testing tool such as the EF Core in-memory provider. So our preferred approach is to use the EF Core in-memory provider because it's been built for that purpose. And we'll use this approach whether or not we're using the DB context directly or if we're implementing, say, the unit of work and repository patterns. Because behind the unit of work or the repositories, there's still going to be a DB context. And what the EF Core in-memory provider allows us to do is to spin up a database in memory and populate it with data and then write tests against that. So we find that much quicker than actually mocking a whole bunch of repositories and filling those up with test data. So what we will do is load up the tests. So I have separated the tests that we're going to write for this service into two different files. There's the read tests and there's the write tests. And can anyone think why I might do that? Yeah, that's right. And because the write tests will have side effects. So yeah, we might want to tear down the data after each write test and rebuild it again. Because otherwise, if we delete a customer in one test and expect to update it in another test, that could cause a side effect, which could cause our tests to fail for the wrong reason. So we also have our write tests class, and I want to show you how they fit together. But to do that, we need to talk about kind of life cycle with XUnit, and so I'm just bringing up the XUnit documentation here. So this is xunit.net, and we're talking about sharing context between tests. And the thing that we want to share between our tests for this particular case is the application DB context. But we want to control how it's shared. For our read tests, for any test that's doing a read test, it can use the same in-memory database because it's not going to make any changes and there's not going to be any side effects. For our write test, we want a new instance for every write test. Even if there's multiple tests in the same class, we want a new instance for every single test there. So there's basically three ways that you can share context between tests with XUnit. The first way is just to implement a constructor and dispose. And so this says, use this when you want a clean test context for every test, sharing the setup and cleanup code without sharing the object instance. So that means when you have a test class with multiple tests, it will run the constructor, then it will run the test, and then it will run the dispose method for every test in that class. Okay? And then the other option we have is class fixtures. So class fixtures are a little bit different. Basically what it says here is you use this when you want to create a single test context and share it among all tests in the class and have it cleaned up after all tests in the class are finished. So we run the setup once, then we run all tests in the class, and then we clean up, okay? So we're not going to demonstrate this one today, but keep it in mind. So the other one, so we're going to use the first one with the class constructor and dispose, and then we're going to use this final one, which is a collection fixture. And you use this when you want to create a single test context and share it among tests in several test classes. So lots of classes, lots of tests, but one setup and one cleanup method. And so we're going to use the constructor and dispose, the first method, for our write tests, and then we're going to use collection fixtures for our read tests. Let's have a look at how that fits together. So to do that, I've created two really simple helper classes. So I have a test base class, and you can see it implements iDisposable, and it has three responsibilities. When the kind of setup action for our tests is to create a new instance of the DB context and assign it to this property so that it can be accessed by our tests. So we have this property, that's how we'll access it. And then the dispose method is to destroy the instance of the DB context. So that's our cleanup. Now, I was refactoring this on the plane this morning, and I used to have actually two separate classes, but I realized I could just use one test base. But there's one thing we have to do, and that's this. We add, this is the collection fixture, and we just say our collection fixture is test base. So we can use this same test base for both read and write tests. It's just that when we do the read test, we're going to reference it by a collection called read tests. So let me show you the factory. So the factory is responsible for creating a new instance of the application DB context. I'll just hide this. And you can see here that it does so using an in-memory database. So when we want to create a new application DB context, we have to pass in the DB context options. Generate the DB context options, we use the DB context options builder. of type application DB context, and we specify use in memory database. And what we're actually saying here is the database name is good.newGood.toString. And we do that just because we want a unique name. This is going to be happening on the fly. We don't know how many tests we're going to write, but there's going to be a lot. And so every time this create method runs, it will create a new unique instance in memory. So have we ever found any differences between in-memory and, say, SQL Server, Postgres, Cosmos DB? Yes. So in-memory is a NoSQL provider, and it's not trying to implement, say, the relational behaviors of SQL Server. So it will behave differently than the SQL Server provider will be. And that's fine, because what we want from in-memory is for it to behave approximately like a real database. Because we're not testing the database here, we're testing behaviors that we created. If we want to test the database, that's when we have to write an integration test, and that's when we'll use the SQL Server provider or the Cosmos DB provider. So yes, so make a clear distinction. When you're using the in-memory provider, you're not testing Entity Framework Core, you're not testing some behavior produced by SQL Server, you're testing something else that you've created. So let's have a look at, so just to follow on that a little bit more, let's have a look at what sort of behaviors we could test in our to-do service that are not related to EF Core or SQL Server or Cosmos. So here's a good example. In the update method, we're expecting it to update a record, and we're expecting it to return null if it can't find the record. So this is a behavior that we can test. Okay, and that's not related to Entity Framework or SQL Server. It's that we expect it to return null if it can't find the entity. So, yeah. Let's see. Okay, so we've got our new context. We've constructed it using an in-memory database. Now we want to make sure it's being created, and then we want to seed it. So I've got a seed helper method here, and we're just seeding it with 4 to-do items. And then we have this context being returned, so this create method returns the new DB context. So it's in memory, ready to use. And the final thing in this kind of class is our destroy method, which just deletes it from memory and disposes of the context. So we use that for our test cleanup and our test setup and cleanup logic. And as we've seen, there's a few different ways we can use it. So let's look at a read test. So for a read test, we want to use the collection read tests. And when we use a collection fixture, we can inject the test fixture, in this case test base, into the constructor. And you can see that I'm just assigning it to a property for access. So now if I need to use the context for my tests, I can just do something like this. Okay, so I have access to the context available, and we know that that resource is being managed well. It's going to be shared among anything that belongs to the read test collection fixture. So it's going to be, performant, and we're good to go. Start writing tests. Then within the write tests, I can just inherit from test base. Okay, so it's going to run the constructor and the dispose method, or the setup and cleanup logic, before and after every single test in this class. So we have just one at the moment, but we can go ahead and add additional, and it'll run those tests before and after. So now we're free just to write the tests, right? We've got all of that infrastructure in place, and we can just focus on writing the tests. So let's write some. So we'll start with a read test, and where's my service? To-do item service. Just put it over this side. We're going to test get all should given, so we'll test something about that. Let's say that we're going to say that should return 4 items. Just based on the test data that we've set up. Obviously, there's not much logic to test here, so the value of this test is fairly low, but perhaps if we were passing in some filtering options, then we'd be looking at how the application behaves with different filtering options. So I'll make this, we'll get rid of that now. Okay, so our service is a new to-do item service. I think it's called to-do item service. and it requires a DB context, and we know we can get that from, this is a read test, so we get it from our test base.context. Okay. Whoops. Whoops. Okay. The action we're going to take here is service.getAll, and we're going to assert the result. Now, there's a special collection methods we can use with should-ly as well. Let me see if it'll tell me via refactoring. Result.count. Oh, hang on. This needs to be asynchronous. So you can see it's very easy to write an asynchronous test. We just mark it as async task. What do we got here? There we go. So we'll run that test. Fingers crossed. It's already run over here. Looks like it's already passed. Down here. There we go, it's all good. We might enable live unit testing for the next test, see how that runs. So if we go test, live unit testing start. Put it down the bottom here. Close this one. I'll kill this off. Not much room there. Now, I have had problems with live unit testing recently, so let's just have a look in the output here and make sure that it starts okay. Okay, it seems good. And you can see we're starting to see those ticks. Now, if we were to go over to our to-do service, we can also see areas which are not covered by tests. And we'd see red crosses if a test was failing. So this is going to continue to run in the background. Whether we're working on implementation or writing tests, we can see these ticks and these crosses and these dashes, and they can give us really good feedback about what we have to test. So, you know, if we were writing a test for the update behavior, and we hadn't actually written a test for this case, it would show that with a dash. It might show ticks everywhere else, but we can see that and we see, okay, I need to actually write a test for that behavior as well. So let's create a write test. We'll just create one write test. There's lots of examples in the clean architecture solution as well. So this is pretty trivial. Our test base is exposing our context there, so we can basically access our context just by saying context. Okay, because it's coming from base.context. Right. So what are we going to write about the add method? So the add method is pretty trivial. So what we might do is just make sure that it's being added to the collection of items. If we were writing this for a repository, we might be checking that add was called. In this case, we're just going to check the context to see if the item can be found. So we'll create a new to-do item. Give it an ID because the in-memory provider isn't going to provide IDs for us. At least last time I checked. Every time I hang around Brendan, my language seems to change from Australia to UK, and I don't know why.
It's just a still fielder project, just trying to correct all the computers out there.
It's ridiculous, and it keeps happening.
Yeah, I'm one of those people that has the magic field. Like, people call me over and their computers start working properly in front of them.
He said the other day we were having a discussion, and he said, well, voice recognition works really well for me because I don't have an accent because I'm English. All right, so we've got our title done equals false, so we don't have to provide the completion. Bring in the references to to-do item. Now we want our service, so we go service equals new to-do item service with an S and a capital I. Bring in the reference for that. We need to pass in our context, which we're going to get from base.context. Leave out the base if we wanted to. Now we're going to take an action. Result equals service.add, and we pass in the to-do item. Now this is asynchronous as well, so we need to change this. Let me make this a bit bigger. You don't need to see too much there. Make that, mark that as async. Bring in system.threading, and where are we? Await. And now we can. What does add return? Not much. There we go. So we're not going to look at the result. What we're going to do now is see if it was added to the collection. So we can do that by trying to retrieve the entity from the context. So say context dot to-do items dot find async, and we pass in the ID, which was the to-do item dot ID, which is 5. And now we want to just take entity and say it should. If we can bring in shouldly, should not be null. Okay, because we need to await that. Find async will return null if it can't find an entity with that ID. And you can see it's already passed. So live unit test is ticking over. If we go and have a look at the to-do item service, we can see we've got ticks for that and pretty much good to go. So yeah, what I wanted to demonstrate there was XUnit, the XUnit life cycles, shouldly, and entity framework core in memory. So I think I've done that pretty well. The only thing I didn't show was the in-memory provider. And that's kind of important. So you can see here that the only reference in the test project is to the in-memory provider. It doesn't reference SQL Server or anything like that. So we're definitely just writing these tests in memory. All right. Any questions about those tests before I move on? No problem. There is if you do want to learn more, and especially about some of the trade-offs, you can go to tv.ssw.com, and we should be able to find this one. Let me just see which one it is. It's one of these. So there's an old version and a new version. Yes, this is the new version. So you can see simplified unit testing was a talk that I did at DDD Sydney in 2017, and it covers this in a lot greater detail. But I certainly like this implementation that I've created here today better than what I was doing in 2017. And of course, as I mentioned, you can see a more advanced implementation in the clean architecture template. All right, so I have some recommended resources, especially if you're new to unit testing or test-driven development, and there's 4 resources. So the first one is unit testing in .NET Core. So it's just the Microsoft Docs. So if you need to get up and running really quickly, just want to get a feel for it in 5 minutes, that's obviously a great place to start. There's lots of valuable resources in the Microsoft Docs. Then there's the bowling game kata. That's by Uncle Bob, and it's a really cool kata. So a kata is something that we practice every day, right? So we come in the morning, the first thing we do is this bowling game kata, for example. And we do that every day for 2 weeks because it gives us a feel for how to solve a particular problem. And I think the problem that the bowling game kata solves really well is getting TDD, getting a really good feel for that test first flow and learning how to drive the design of your application using TDD. So if you did this every day for 5 days, you get a really good feel for that. And then my next recommendation is in the following week, do it again for 5 days, but this time learn the keyboard shortcut. So every time you go to grab the mouse, use it as a way to actually become a keyboard ninja. You'll get really fast, really quick, because it's just a great opportunity to do that. And then of course go and find a different kata and solve some other problems. It would be really useful. So then we have the book, Test-Driven Development by Example by Kent Beck. So this is the Bible as such. It's divided into 2 parts. The first part is the by example part, where you follow along and actually build up an application. And the second part is kind of the patterns and practices. So both parts of that book are really interesting and definitely worth a read. So the next and final resource is The Art of Unit Testing by Roy Osherov, and this is a more modern one. I like this one because the examples are in C# and it talks about some of the more modern mocking tools and things that you can use when you're unit testing today. If I had to pick just 2 resources, I used to say just one, but I can't really pick just one. I would say stick with the bowling game kata and then The Art of Unit Testing, but there's definitely great value in all 4 resources. Okay, key points. Write your test first. It's the only chance you'll get. Unit tests for core layers. Actually, I forgot to update this slide. So this is kind of taken from my clean architecture template, and what I'm saying is that in the context of clean architecture, where we have this core, where we write all of our business logic, we want to write unit tests for that. Integration tests for our infrastructure. So when we can't write a unit test, we have some dependency on infrastructure, obviously aside from SQL Server, where we can use in-memory provider. If we had a dependency on an external web API, for example, then we can write integration tests for that, especially if we're trying to test the interaction between kind of our services and their services. UI test sparingly for presentation layers, and use the EF core in-memory provider where possible.